Look around any city and you'll see them cranes. These towering machines are essential for building our world. From skyscrapers to bridges, cranes lift and move the heavy stuff, making the impossible possible. But have you ever wondered how they actually work? How do they lift such massive loads so effortlessly? Let's find out. Imagine trying to lift a car with just your bare hands. Impossible, right? Now imagine using a long, sturdy beam as a lever to help you lift that car. That's the basic principle behind how cranes work. They use a combination of simple machines, levers, pulleys, and hydraulics to generate immense lifting power. This essay will explore the fascinating world of cranes, breaking down their mechanics and showing how these engineering marvels help us build bigger and better. We'll look at the different types of cranes, their unique strengths, and the crucial role they play in shaping our skylines. At the heart of a crane's lifting power lie two fundamental simple machines: levers and pulleys. These simple yet powerful tools have revolutionized the way we build and move heavy objects. These basic mechanisms, known for centuries, form the backbone of a crane's operation. From ancient times to modern construction sites, the principles remain the same. Think back to your childhood seesaw. That simple playground equipment is a perfect example of a lever in action. That's a lever in action. It demonstrates how a small force can lift a much larger weight with the right pivot point. A lever is a rigid bar that pivots around a fixed point called a fulcrum. This simple machine amplifies the input force to lift heavier loads. By applying force to one end of the lever, you can lift a weight on the other end, even if it's much heavier than you. This principle is used in many tools and machines. Cranes use this principle with their long booms acting as levers. The boom's length and the position of the fulcrum determine how much weight can be lifted. Pulleys, on the other hand, work by changing the direction of force and reducing the effort needed to lift a load. They are essential in making lifting tasks easier and more efficient. Imagine trying to lift a heavy bucket of water straight up. The effort required can be overwhelming and impractical. Now, imagine using a rope and pulley system to lift it. Much easier. The pulley reduces the amount of force needed, making the task manageable. Cranes use a system of pulleys to distribute the weight of the load, making it much more manageable to lift. This system allows cranes to handle extremely heavy objects with precision. By combining levers and pulleys, cranes can lift incredibly heavy objects with surprisingly little effort. This combination maximizes efficiency and power. It's a testament to the power of simple machines when used cleverly. These fundamental principles continue to shape our world, enabling feats of engineering that were once thought impossible. While levers and pulleys provide the mechanical advantage, it's the hydraulic system that gives cranes their brute strength. Hydraulics is the science of using liquids to transmit power, and it's what allows cranes to lift and move those massive loads with such precision and control. Think of a hydraulic system like a giant syringe. When you push on the plunger of a syringe, it forces the liquid inside to move, creating pressure that can be used to do work. Cranes use a similar principle, but on a much larger scale. A crane's hydraulic system consists of a pump, a reservoir of hydraulic fluid, and a network of hoses and cylinders. The pump pushes hydraulic fluid through the hoses, creating pressure that extends or retracts the cylinders. These cylinders in turn move the crane's boom, adjust its angle, and power the hoisting mechanism. Without hydraulics, cranes would be much slower, less powerful, and far less versatile. It's the muscle behind the machine, enabling these gentle giants to perform their heavy lifting with grace. A crane's impressive capabilities come from the harmonious interplay of its various parts, each working in unison to perform complex lifting tasks. Let's break down the anatomy of a crane, exploring the key components that make these machines tick and allow them to perform such heavy-duty operations. The boom. The most recognizable part of a crane, the boom is the long, lattice-like arm that extends upwards, reaching towards the sky. It acts as the lever, providing reach and height for lifting operations, enabling the crane to move loads to great heights and distances. The jib. Some cranes have an additional smaller arm attached to the end of the boom called the jib, which extends the crane's reach even further. This jib provides even greater reach and flexibility for positioning loads, making it easier to place materials precisely where they are needed. Counterweights. Ever wondered why cranes don't topple over when lifting heavy objects? The secret lies in the counterweights. That's where counterweights come in, playing a crucial role in maintaining the crane's stability. Located at the rear of the crane, these massive blocks of concrete or steel act as a counterbalance, preventing the crane from tipping forward and ensuring safe operations. The hoist. This is the heart of the lifting mechanism, responsible for the actual lifting and lowering of loads. The hoist consists of a motor, drum, and cables that work together to lift and lower the load, ensuring smooth and controlled movements. The crane operator controls the hoist from the cab, using a series of controls to manage the lifting process. The operator's cab. Perched high above the ground, the operator's cab is the crane's control center, offering a commanding view of the job site. From here, the operator has a bird's-eye view of the job site and uses a series of levers, joysticks, and controls to maneuver the crane and its load with precision, ensuring every movement is executed safely and accurately. Section 5. A family of cranes, each with unique strengths. Just like there are different tools for different jobs, there are different types of cranes, each designed for specific tasks and environments. These cranes are engineered to handle specific challenges and excel in their respective fields. Tower cranes are the giants you see towering over city skylines. They are the backbone of urban construction, enabling the creation of the tallest buildings. Tower cranes are fixed to the ground and can reach incredible heights, making them ideal for constructing skyscrapers and other tall structures. Their ability to lift heavy materials to great heights is unmatched. As their name suggests, mobile cranes are mounted on trucks or crawlers, allowing them to move around a job site with ease. This mobility makes them indispensable for projects that require frequent relocation. They're incredibly versatile and used for a wide range of lifting tasks, from loading trucks to assembling bridges. Their adaptability makes them a favorite in many construction scenarios. Crawler cranes are heavy-duty cranes mounted on tracks like a tank, giving them excellent stability and mobility on uneven terrain. This makes them perfect for challenging landscapes. They're often used for heavy construction projects such as building dams and power plants. Their robust design allows them to handle the most demanding tasks. Telescopic cranes feature a boom that can extend and retract like a telescope, providing adjustable reach for various lifting needs. This flexibility is crucial for tasks that require precision. They're commonly used in construction, rescue operations, and even tree removal. Their ability to adjust their reach makes them highly versatile. Found inside factories and warehouses, overhead cranes are mounted on a system of beams and rails, allowing them to move heavy materials horizontally across the ceiling. This setup maximizes floor space and efficiency. They're essential for manufacturing and logistics operations. By streamlining the movement of materials, overhead cranes play a critical role in maintaining productivity and safety in industrial environments. Section 6. Building a giant crane assembly and operation. Erecting a crane, particularly a towering tower crane, is an impressive feat of engineering in itself. It's like putting together a giant complex puzzle, requiring careful planning, specialized equipment, and a skilled team. The process typically involves assembling the crane's base, and then using a smaller mobile crane to lift the tower sections into place. As the tower grows taller, the crane actually helps to build itself, lifting each new section with its own hoisting mechanism. Once the tower is complete, the boom is attached, and the crane is ready for action. Operating a crane is a highly skilled profession. Crane operators undergo rigorous training to learn how to control these massive machines safely and precisely. They must be able to assess load weights, calculate center of gravity, and maneuver the crane with accuracy, all while maintaining constant awareness of their surroundings. Section 7. In safe hands, regulations and expertise. With great power comes great responsibility. Crane operations are subject to strict safety regulations to prevent accidents and ensure the well-being of workers and the public. Crane operators must be certified and licensed, and cranes undergo regular inspections and maintenance to ensure they're in top working order. Safety protocols are in place for every aspect of crane operation, from rigging loads securely to communicating effectively on the job site. Behind every crane operation is a team of skilled professionals, including engineers, riggers, signal persons, and of course the crane operator. Their combined expertise ensures that lifting operations are carried out safely and efficiently. Section 8. Advancements in crane technology. Reaching new heights. As technology advances, so too do cranes. Modern cranes are becoming increasingly sophisticated, incorporating computer-aided design, telematics, and advanced control systems to enhance safety, precision, and efficiency. Some cranes now feature load moment indicators that provide real-time feedback to the operator, alerting them if the crane is approaching its lifting capacity. Others use GPS technology for precise positioning and anti-collision systems to prevent accidents on crowded job sites. The future of cranes is looking even more innovative, with concepts like autonomous cranes and robotic rigging systems being explored. These advancements promise to further improve safety, productivity, and sustainability in the construction industry and beyond. Section 9. Conclusion. The indispensable crane. From the simple lever and pulley to the complex interplay of hydraulics and modern technology, cranes are a testament to human ingenuity. These remarkable machines have become indispensable tools, shaping our world by lifting the impossible and helping us reach new heights. The next time you see a crane, take a moment to appreciate the engineering marvel behind it. It's a symphony of science, skill, and precision, working tirelessly to build a better future, one lift at a time.